Okay, first thing, my variable in the equation is not x, it's k. So I need to make one minor change here to my quadratic formula. I need to replace the x with k. Okay, now, let's see here. I need to get rid of the fractions. And I do this the same way I've done before. If I was looking for a common denominator between these fractions, I'd be finding a common denominator of 6. So I'm going to multiply each term by 6. So I'm going to multiply this by 6, and I'm going to multiply this one by 6, and this one by 6, and the 0 by 6. So when I do that, let's see what happens here. That 6 and that 2 are going to cancel, leaving me with a 3. And over here, the 6 and the 3 are going to cancel, leaving me with a 2. So now let me go ahead and multiply this out. So 3 times 3 gives me 9k squared minus 6k. And 2 times 4 is 8, so this is minus 8 equals, and 0 times any number is still 0. Okay, now I can plug it into the quadratic formula. So let's see here. My b is negative 6, so negative b, and let me change colors here. Negative 6, which of course will be positive 6, but we'll deal with that in a minute. Plus or minus the square root of, okay, b squared, so negative 6 squared minus 4 times my a is 9, and c is negative 8. And that's all over, extend this a little bit, 2 times, and my a is 9. Look like a 9. Yeah, let me fix it. There we go, now it looks like a 9. Okay, so now I get to start simplifying. Okay, negative 6 would just be 6, plus or minus the square root of, okay, negative 6 squared, I now have 36, minus, let's see here, 4 times 9 times 8, times negative 8, so let's see here. First of all, minus and negative, those are going to cancel and give me plus. And now, let's see, 9 times 8 would be 72, and then I need to figure out 72 times 4. You know what, let me change colors just so I don't confuse myself. Okay, 72 times 4. Okay, so I now have plus 288. I should change my color back. And that's over 2 times 9 is 18. Okay, so 6 plus or minus the square root of, and 288 minus 36. That's going to give me 252, and I need to find the square root of 252. Gee, how can I do that? How about if I factor? Well, let's take that 252. It's definitely divisible by 2, and when I divide it by 2, I'm going to get, 2. When I divide it by 2, I'm going to get 126. Also divisible by 2. When I divide that by 2, I'm going to get 63, which is divisible by 3. And it gives me 21, also divisible by 3. And that gives me 7. Okay, so let me circle my primes. Okay. Set of 2 right here, so there's a perfect square. That equals 2. Another set of 2 right here, a perfect square, and its square root equals 3. And then I've got one left over that's going to be inside of my square root. So now coming back here, let me back up. Okay, so that was over 18. And now 6 plus or minus on the square root of 252 then is 2 times 3, which is 6, times the square root of 7. And that again is over 18. Okay. And simplifying from here should be fairly easy. 18 is divisible by 6, and both of them have 6's. So that's going to turn into a 1, plus or minus the square root of 7. And when I divided 18 by 6, I got 3. So what happened here, we canceled this, each of those became a 1, and this became a 3. So I ended up with, and my variable was, let's verify here, k, correct? Yes, my variable was k. So k equals, let me rewrite that so it's a little easier to read. K equals 1 plus or minus the square root of 7 over 3.